Hello guys, I'm back. This is a video that I'm kind of going to answer a question on. Phil from Steel City 321PB had asked a question about something. Well, what boils down to when I had the last video I put up showing the Airline radio playing and stuff, and I said something about that I would take and touch the antenna lead, even though I had a wire on it. I'd touch it and it would come in better. You'd get louder sound. And he asked about if I could possibly talk about that or answer that question of why would that happen. And that's what we're going to do on this video. For one thing, one thing I need to say is in the description I'm going to put several links, and I really think you should go to those and read up on, because I'm just going to touch in a nutshell what's actually going on and why this phenomenon happens. People's asked this and talked about it before, where you can, like touch an antenna lead or something. Maybe you don't have a real good antenna, just a few clip leads like I had, and you touch it and it comes in better. Maybe you got one of the little newer radio that's got the ferrite rod antenna in it, a little rod of ferrite and then a coil around it. You grab a hold of it and touch it. The radio seems to respond and come in better for the most part. Most of the time that happens. And a lot of them just, a lot of people have said that basically you're just an antenna and you're just capacitive or inductive coupling. Well, actually you're capacitive coupling for one thing. And yes, you are an antenna, but why are you an antenna? I mean, standard thought in making an antenna is you figure up from your frequency what your wavelength is, and then you would take either use a full wavelength antenna, which is fine if you're real high frequency, but if you're working with like the broadcast band or some low frequencies, excuse me, that can get extremely long, and wavelengths measured in meters. And you can get several meters. Ham radio operators operate in several different meter bands, such as like the 80 meter band or and 160 meter band. Well, if you wanted a full wavelength antenna for the 160 meter band, you would be looking at 160 meters long for an antenna, and that would just be the main part of the antenna. So what a lot of times is done is that they break the antenna up in even fractions, like a half wavelength, quarter wavelength. Although the shorter you make it, the less it is capable of picking up. It loses some of its sensitivity and gain as you break it down. Now the other problem you run into, what if, it's nice to say something like the 160 meter band or the 80 meter band or something like that, but that can encompass several frequencies actually in that band. Just like the broadcast medium wave is covering several frequencies. Well, to really truly make a good quality, high gain, super efficient antenna, you would have to have that antenna set either at full wavelength or at least half wavelength, and then for every single frequency. So you would say on the broadcast band, you'd have to have it set for the lowest frequency and the next frequency up, at least all the frequencies that you can pick up, stations in your area or that you want to pick up, and make several different antennas. And that presents a problem, and no one's going to have an antenna like that, and you just, so a lot of compromises are made and everything. But now wait a minute. What about cell phones? If you think about it, your cell phone does a lot of things. You don't just talk on it. You can text on it. You can go on the internet. It's got Wi-Fi, Bluetooth. It does several different frequencies in there, and it doesn't have several different antennas, and it doesn't have all these things sticking out and different links and everything. Your Wi-Fi frequencies could be different than the talk portion of it, which is different than the text portion, which is different than the data portion, which is different from everything else. So how's that done? How do you do that? Well, it's the same reason why your body makes a good antenna. And that's what we're going to kind of touch on in a nutshell. I'm not going to go in depth on this. But what I've taught you so far in math has been what is known as linear math. And that's generally, most math is linear. No matter how you look at it, whether you're doing a real basic math problem such as 2 plus 2 is 4, or you're dealing with trying to find the resonant frequency using the formula that's in algebra and stuff, that's all linear. Trigonometry, linear, and so on. Calculus, all this is linear. Mathematics. Well, there happens to be another realm of mathematics. Nature is not linear. In fact, there's nothing in nature that's linear. Nothing in the universe that's linear. The only things that are linear is what we create. We create boxes for buildings and rectangles and all kinds of stuff, and let's face it, all the test equipment I've got's in some sort of box and shapes of that nature. Your screen that you're watching this on is a rectangular screen. It's all linear. But these are things that we created. But in the natural sense, in nature, they're not that way. They follow a different set of rules. And it's called fractal geometry. And fractal geometry is, in a nutshell, is where you take a particular pattern and then you just repeat it. No matter how big it gets or how small it gets, it just repeats. And two things happen. One, it repeats forever. And two, it's not linear. It can have all kinds of shapes. And one quick little simple way of showing fractal geometry is I've got a triangle. It's supposed to be an equilateral triangle, but I'm not an artist. But one thing you can do is we just take and break out a side, break out a side, break out a side, and put another equilateral triangle there. There'd be a triangle. But that's fine. I just repeat the pattern. But what if I do this? And do that on all those other little triangles. And then do that again. And again. And again. And again. And again. On every new triangle I put around there. It keeps going and going and going. Effectively, if I run that in a computer simulation and keep doing that and keep doing that, the actual length all the way around is infinite. It never ends. No matter how small you go, it's this pattern. It's actually just a triangle, then a little star, and then smaller and smaller and smaller. But it keeps repeating that pattern forever. That's fractal geometry. I shared a video that was on Nova, on Google Plus, so check it out. It talks about the guy, the great mathematician of our century, who not did this pattern, but he did another pattern like this, but he actually coined the term fractal and gave it a name. He also stated that that actually he could use fractal geometry to measure the coastline of England dead accurately. And he actually had done that. It's not shown on the video that he actually did it, but he actually did work up the math and did it. The interesting thing is, in his math on that and the geometry of it and the fractal, it actually showed that any coastline can be measured dead accurately, except for one little problem. It goes on actually continuously. It's how small you want to go is, where you stop at. But what does that do with an antenna? Well, everything in nature is fractal, including the human body. We're part of nature, so everything in us and everything of us is fractal. Our circulatory system, our nervous system, just the cells in our skin itself, and the cells, how they are positioned and everything. The whole works is fractal. And that our actual shape is a fractal. And by that being, then when I touch the antenna lead, or you touch the antenna lead or anything, you actually become a much more efficient antenna than a regular antenna is, because you're fractal. The waves that are being sent through the air, those radio waves, actually follow fractal rules also. And your body, they will find a perfect wavelength in your body, a perfect fraction of that wavelength, but they will find it and make use of it, and it will be dead perfect for them. And consequently, you become a higher gain antenna than the wire that you put on it. I talked about your cell phone. Well, your cell phone uses fractal antennas. They're basically rectangles, and in a nutshell, they would kind of look like this. There'd be little ones here. Well, that's not a real good square. All the way around it, and then this would be connected. You'd have a repeating pattern of bigger ones and bigger ones, and just imagine all these just completely repeating all through here, down smaller and smaller and smaller. And what that allows is different frequencies can interact with that antenna, because it can find different spots in the different rectangles. These would all be just, copper, and there'd be little ones inside with just small breaks. In between them, except where they're connected. And this would just go on almost continuously within the allowance of manufacturing. You can only manufacture so small. But the point is what they do is, no matter what frequency that is affecting this antenna, it can find some spot on that antenna that fits its wavelength perfectly. And so that's what they ended up doing, putting in cell phones. Now, they don't have to be the rectangle shape. They can be other shapes. There are shapes, and when you look over those sites, you'll see different shapes or different antennas. There can be shapes such as just the triangles. You can have an antenna kind of coming like this, and then like this, like this. Again, I'm not much of an artist. And so on. Just think about several tiers of those, several different ones all the way around, making up an antenna. Or you can use triangles, you can use whatever to create the antenna. And the interesting thing about this, most of this is actually pretty simple math in a way, but basically one of the primary things that it does is to repeat a pattern is all you got to do is you set up something like, okay, like maybe a rectangle, the base formula for a rectangle, but then when you get the answer, you replug that answer back into the formula and do it again and again and just keep replugging it in. Now the problem was fractals didn't really get tremendously accepted right away, and one other thing was they were almost impossible to deal with because of the actual just redoing the math over and over and over and over and over and over again. You'd have to do it hundreds of thousands and thousands of times to get a pattern, to repeat the patterns and repeat the math equations until the computer came along. It can do that work. It can crunch the numbers and do it. The other problem is that it didn't get accepted in the mathematical world because it's nonlinear, and mathematicians didn't like it because of that fact. They just felt it was just a little thing that is nice for art and nice for running a computer program or something, but that's about it. Until more recently it found place in technology, in electronics and computer software, as well as regular software, and computing itself, and the electronics in it, and the hardware, and antennas and stuff. And that's when they started learning more and more about it. Everything you look at and look around is nothing but fractals, and they're just a representation of a whole. The leaf, the veins in a leaf actually represent, on any one tree, represent the entire tree. The limbs, the number of limbs, where they're located, everything. You can actually take a tree that's in a forest, look at that tree, look at the limbs, look at the size of the limbs and everything, and it will actually tell you location and sizes of all the other trees that's in the forest, because fractals just build on themselves, and they start from the smallest point and work up into a repeating pattern, constantly repeating. So anyway, look up those links. In a lot of them, they do talk about antennas in general and stuff. They also talk about fractals in nature, and the history of them. A lot of different big name mathematicians that worked with them, and I think you'll find it quite interesting. But it much more in-depth explanation why, other than just simply that you're just a big mass that you're grabbing hold of that antenna lead. It makes it easier for the radio waves to hit. It's more importantly that some part of your body actually represents a perfect, if not the whole body, represents a perfect wavelength resonant antenna, better than the wire antenna that's hooked to it. So fractals and fractal geometry, everything in nature follows those rules, and they're actually pretty simple rules, but everything follows them. And modern day antennas are made for them, and including your digital TV antenna, it's fractal. Wi-Fi antennas are fractal. All this is fractal. So thought I'd just answer that question. I know it's just a nutshell answer. Didn't give you really any math at all, but if you want to understand or look at the math and stuff, like I said, in the description will be the links to those, and you can also look at that shared video on Google Plus that I shared, and just enjoy. It's a fantastic, fascinating math and science, and I think you'll find it quite interesting. Well, thanks again for watching and for your comments. I've been working on answering some of them. I'll continue doing that. So, see you on the next video.